So real quick, I gave you guys a method that I really would hope you would buy into fully. It's going to make it a lot easier when we get to fractions that have variable stuff on the bottom. That's in our future. Oh shit. So what I mean is something, so to do a problem like 1A, if I had 4 over, what you got, Jeff? 15 minus 1 over, what is it, Jeff? Let's do 27, I like it. Yummy. So I gave you a way to do this that you could always use, unless it's something easy like 1/2 plus 3/4. I mean, you can see the LCD is 4. But here, what do they both have in common, the bottoms? What do they both have in common? 3. Rewrite them as 3 times something. Then you'll see what they're each missing. They already both have a 3. What's 15? And what's 27? So now you can see easily what they're each missing. What is he missing that he's got? What's he missing that he's got? A 9. What's he missing that he's got? 5. Because the whole purpose is to make the bottoms the same. So this idea of giving them each what the other one's got that they're missing makes beautiful sense. You're going to end up with the same stuff on the bottom. So I get 36 over, what's 3 times 5 times 9? Oops. I think it's 135. Is that right? I was just going to, sounds good, Jeff. You're the math guy for shit. You don't know. All right, it is minus 5 over 135. And what would that be? 31 over 135. Okay, and that actually won't reduce. I think everybody's 1A reduced. And if you didn't reduce, you lost some points. Real quick. All right. Is that cool? Whoever asked that question, is that decent? I mean, you do the same thing. Do you guys know how to check to see if a number is divisible by 3? Oh, sorry.
Real quick, sorry.
Yeah.
You multiply all 3 of those numbers?
Yes.
Okay.
Yeah. 3 times 9. Like, for example, I know that this number is divisible by 3. Can you do it, Jeff? 3. There. That number is divisible by 3. Does anybody know how to check that? I mean, yes. See, it's crazy. And once I tell people this, they're like, why didn't anybody tell me this earlier? And they just kind of shoved it out of the curriculum because they're like, calculators can do it. And we're the freaking humans. We better know some shit so the calculators don't take over someday. Right? Because eventually I'm going to give them my eyes, and then that's it. Look at this calculator. No, I don't want to. Screw you. Do what I say. So the rule, now everybody should know 2. 2 goes in if the number is even. Correct? 3 goes in if all the digits add up to a multiple of 3. See if Jeff did this in his head right. 3, 10, 16, 17, 18. Is 18 a multiple of 3? Therefore, 3 goes into the whole damn thing. 9 has the same rule. This is also divisible by 9 because 18 is a multiple of 9. It makes sense that 9 and 3 would have sort of the same rule because they're multiples of each other. Right? 9 is 3 times 3. Has anybody ever heard that before? Isn't that really flippin' useful? So if you had 108 over 3,072, right? And actually it may make it even more than 105. It may make them there. And you're like, you got to reduce this thing. They're not even. It's like, what the shit goes into these? 1 plus 0 plus 5 is 6. That's the multiple of 3. 3 plus 7 is 10, plus 2 is 12. That's the multiple, so 3 goes into both. Hey, there's a number to start with. That's fantastic. See how stupid useful that is? Even if calculators exist, you still have to have an idea what the shit to put in. If you have no idea what to try, then what the shit? You guys kind of with me? Anybody? All right. Some of you guys are like, I knew that already. What about 4? Anybody know about 4? How to tell if something 4 goes into something? So 4 goes into this number. Why does 4 go into that number? The last two numbers. Since 4 goes into 24, 4 goes into this thing. And you can just memorize that as a rule, but why does that make sense? Because 4 goes into 100. Since 4 goes into 100, 4 goes into 104, 4 goes into 108, 4 goes into 200, 4 goes into 204, 4 goes into 1800, because it goes into 100. So as long as the last two digits 4 goes into them, that means the whole thing is divisible by 4. Has anybody ever heard of that rule? No. Is it a little bit useful? Shit, yeah. All right. 5. You guys know 5. Can't escape knowing 5, thankfully. 5 or 0. 6 means it's even and the numbers are multiple of 3. If it's even, 2 goes into it. And if it's a multiple of 3, 3 goes into it. That's 6 goes into it. 2 times 3 is 6. So if it's even and 3 goes in, 6 goes in. Because that's 2 times 6. 7 has no rule. Poor little 7 dude. 9 we're talking about. 8 I'm not going to worry about. Anyway, so those are out there. And everybody used to know them. And now nobody knows them. And that is bullshit, to be honest. Right? Okay. Or if you don't agree, well then, all right. You can forget them. Okay, so let's come back into what we were doing. We were about to get into everybody's favorite word problems, but first we were talking about percentages. We talked about how to go from percent to decimal to fraction and all the other ways. Right? We talked about a hat problem, which is always exciting. Let me ask you this. Does somebody have a way to solve this question? 7 is 14% of what? Anybody have a way to solve that? Yeah, but why? So, yeah, exactly. This is what I call pseudo-math. This is one step away from math. This is like somebody reading an equation. 7 is, what's that in mathish? 7 equals. What's 14% in pure math? What number is 14%? 0.14. What's of mean? Multiply. And what's what? No. In algebra, when I don't know what I call it x. Now, x is much better than a blank spot. If I put an x, then I can manipulate it. That's the whole reason we came up with variables. They take the place of the shit I don't know, so I can work with it to hopefully figure out what it is. So it really is, it's better than a blank spot. I put an x instead, right? So 7 is 14% of, I don't know. How do I solve for that? Divide by 0.14. But if your problem is given to you in this format, it is one step away from an equation, and then you just solve the equation. That's too beautiful. Some of you guys know is over of and all that bullshit. That just is adding layers on top. It's crazy. This is just goes right into an equation. How do I solve for x? I divide by 0.14. Yeah. Somebody in the next room is really making a point.
Morse code.
7 divided by 0.14. Let me see if you guys can get this. 7 divided by 14 would be a half. Is that cool? 0.5. So 7 divided by 0.14, this would move ones twice. Whoa. 50. You're like, whatever, dude. I got it covered. All right, whatever. Some of you guys maybe see what I did there. I don't know. So another way to look at it is, how do you divide by decimal? Don't you move this over? Like if I had it like this, 0.14 into 7, what would be the first thing you would do? Somebody remember long division? Move this over. If you move this over, what do you have to do at the same time? Because, now look how that makes sense. That means I'm multiplying top and bottom by 100.
Yeah.
I'll multiply this by 100, so I better multiply that by 100. 7/14 is 0.5. 714 is then 100 times as big. 50. Or plug it in your calculator, I don't care. Right? But hopefully somebody got something out of that. You can work with division by decimals. They're not horrible sometimes. So that means that this answer is 50. 7 is 14% of 50. What's 14% of 100? 14. So how do you get 7? Half of 100 to make it half of what it was. So that's 14% of 50 would be half of 14% of 100. I mean, everything connects back to itself. Okay. So let me give you this. Only worry about the side that says section 2.4. The other side is 2.5. That's true word problems. We're not quite there yet, so don't freak yourself out. Yeah, exactly. So you can generalize that.
There was a whole number on there. Stop playing.
So you guys can work together if you want to.